Welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 5 from my end of topic worksheet on differentiation from P1. And this is a question also from the Solomon C1 collection, which is question number 10 from that. And it's a question about differentiation. It says figure 1 shows the curve with equation y equals 2 plus 3x minus x squared and the straight lines L and M. Okay, so we have the curve y equals 2 plus 3x minus x squared. You can see this frowny face type of curve, quadratic, and the straight lines L and M. The line L is a tangent to the curve at the point A, where the curve crosses the y-axis. Find an equation for line L. Okay, so now we know that this curve crosses the y-axis at the point A, and the line is a tangent to the curve at that same point. Now they want us to find the equation for the line, the tangent, the line L. Okay, so the equation of a tangent is a straight line. Okay, a tangent is a straight line. So we need to find the equation of a straight line, for which we need two pieces of information. We need to know two things. We need to know the gradient of that tangent, and we need to know a point that it passes through. Okay, and we know that it passes through the point A, which we have the x coordinate is 0, and we have to find the y coordinate. That's what's missing. So if we find the equation of the tangent, or the value of the tangent to the curve at that point A, and the y value of the point A, we can then write down the equation of the line L. Okay, so the first thing we can do is we can find the point where it passes through the y-axis, because it's the same point where this curve passes through the y-axis. So where does it pass through the y-axis? When y equals 2 plus 3x minus x squared, it passes through the y-axis when x equals 0. And we can see when x equals 0, y is going to be 2. The y-intercept is 2. So that's also the y-intercept of the curve, of the straight line, the tangent. So the tangent passes through the curve, passes through the y-axis at 2. Okay, the same place where the curve does. Now we need to find the equation or the gradient of the curve at that point where x equals 0. So to find the gradient of a curve, we can use the gradient function, which is found by using differentiation. So we have y equals 2 plus 3x minus x squared, and we need to find dy dx. Alright, so when you differentiate this with respect to x, the constant becomes 0, the x term drops to x, and you've got to multiply by the power of minus 2x to the power of 1, which is not written. So at x equals 0, which is where a is, okay, and where the curve passes through and the tangent hits the curve at that point, x equals 0, that means the gradient of the tangent will be 3 minus 2 times 0, which is equal to 3. So we know the gradient of the tangent is 3. So now we have enough information to find the equation of the tangent. The equation of the tangent, therefore, is going to be found by y minus y1 equals m times x minus x1. So we have y minus the y value, which is 2. In fact, we don't even have to do this because we have the y-intercept here. So equals 3 times x minus the x value. So you can see you're going to have y minus 2 equals 3x. So y equals 3x plus 2, which in fact we could have written down straight away, because we know that in terms of y equals mx plus c, we have m, which is 3x, so it's 3x, plus the y-intercept, this is the y-intercept 2. So you could write the equation down straight away, in fact, once you know that this is the y-intercept. If it says 0 for the x value, then that is the y-intercept. So you can write y equals 3x plus 2. So that's an equation for L. They didn't say in which format they want it, so we can leave it as y equals 3x plus 2. That's absolutely fine. And there's the answer to part A. Now for part B, now we know the equation of line L is y equals 3x plus 2 from the last question. And now it says the line M is the normal to the curve at the point B. Given that L and M are parallel, find the coordinates of B. Okay, so we know that the gradient of the line M and L are the same. Okay, so it's a normal to the curve at B. Now a normal to the curve is perpendicular to the tangent to the curve. So at the point B, okay, the gradient of the curve at the point B will be the negative reciprocal of the gradient of the normal. Okay, so we can say that the gradient of M, the gradient of the line M, is equal to 3. because it's parallel to the line L. They have the same gradient. Therefore, we can say the gradient of the curve, at B is going to be negative 1/3. Negative 1/3, because that's where you're going to have the negative reciprocal. Okay, so negative 1/3. Okay, so the gradient of the tangent and the normal are negative reciprocals of each other. So the gradient of the curve at B is negative 1/3. So if we can find where the gradient of this curve is equal to negative 1/3, we can find the coordinates of B. Okay, so let's, again, we've got y equals 2 plus 3x minus x squared. We already found dy dx, which is pretty simple to find. It's going to be 3 minus 2x. In fact, we didn't find it, I think. No, we didn't find it. Okay, but anyway, yes, we did. Actually, we needed to find the gradient at A. So anyway, we found it already. It's not too difficult to find it again. So dy dx equals 3 minus 2x. Okay, so now we can find, we want to find the coordinates of B. We know at B, the gradient, which is dy dx, is equal to negative 1/3. So if we equate this gradient to negative 1/3, we can find the x coordinate of B. So we say 3 minus 2x is equal to negative 1/3. Let's get rid of the fraction, multiply both sides by 3. We have 9 minus 6x equals negative 1. So we're going to have 9 minus 1, which is 9 plus 1, which is 10, equals 6x. So you're going to have x equals 10 over 6, which is 5 over 3. And to find the y coordinate of B, we say y is equal to 2x, plus 3x minus x squared. So when x equals 5 over 3, y is going to be 2 plus 3 times 5 over 3 minus 5 over 3 squared. Okay, when you calculate that, you have y equals, that's going to cancel with that. You got 2 plus 5 minus 25 over 9. So y is equal to 7 minus 25 over 9. So y is equal to 63 over 9, which is 7 minus 25 over 9. So you got 63 minus 25. That's going to be 38 over 9. So we say the coordinates of B are 5/3 and 38 over 9. And there we have the answer to that question. Okay, so we found that the normal to the curve at B must have a gradient which is perpendicular, okay, to the gradient of the tangent at A, because we know that it tells us it's the normal to the curve and it's parallel to the line L. So if parallel to the line L, it's going to be perpendicular, okay, to the tangent at B. Okay, and the tangent at B is a gradient of the curve at B. Okay, the normal to a curve has a gradient at that point which is perpendicular to the gradient of the curve. So we can see the normal to the curve here has a gradient of 2. That means the curve must have a gradient has a gradient of 3. So the normal to the curve has a gradient of minus 1 over 3. Okay, so we can find the gradient function and equate to minus 1/3, and then solve for x, which we did in the gradient function, and then replace the x in the original function with 5 over 3 to find the y coordinate of the point, and we've got the answer. Okay, so that's the end of question part B. I think that was it. Yes, that's the end of that question. And other questions from this particular paper of Solomon L, you can find in the playlist that will appear over here. Other questions from this end of topic worksheet, the end of topic worksheet on differentiation from P1, you can find in the playlist that will appear in this area. And the playlist on this side here will be a general playlist of all the P1 differentiation questions I've answered. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.